Good evening once again, all of the participants, and thank you very much to show your interest in this ongoing program. And I hope that all the things which I am trying to present for you are really valuable and applicable for you. And the content which I am trying to share with you, script file, the recordings are always there. You can log in your account anytime, and along with the script files which help you in many ways, also reduce your time, and all the script files which I always upload in your account are errorless. So just downloading the script file and then using not sufficient. As I repeat many times, you must try to write your own MATLAB code. First, understand the method, then because the methods which are available are not in the form of iteration method. Okay, so we need to convert in iterative format, and then after this will help us to write the MATLAB code. Okay, so the if you have any question before starting the session, please feel free to ask from me, and then after we will start. Today we have only one method, and that is a little bit similar to the previous one. All the many things now familiar with all of you, because how we can give the initial values, okay, how you can make a line space, how you can write a user defined function. Only one thing which is change always, that is method. Okay, rest all the other things for the plotting and for the initialization, all these things are similar in all the methods. So just we are trying to focus only on the method, what are the steps are involved, how we can initialize, and then to initialize, we need to convert in iterative format. Date format always help us to convert in the MATLAB code. Okay, sir, usually we work on XT, but how to create MATLAB code for plotting variable? Can you please unmute your mic? I don't get your exact question. Someone put
सर
in the chat. Yes, please.
सर नॉर्मली हमरा मतलब हम लोग टाइम के रेस्पेक्ट पे प्लॉट करते हैं कोई भी वेरिएबल और टाइम। तो अगर कोई ऐसा कुछ है मतलब dx dt इक्वल्स टू a एक्स टी माइनस b एक्स वाई टी, ऐसा में हम अगर करना चाहे x के रिस्पेक्ट पे टी टाइम के जगह a या फिर b, ऐसा कुछ तो कैसे प्रोग्राम बनाए मैटलैब पे?
Yes, if you can send any problem which you want to discuss, this will help me. We can do everything in MATLAB, but as you are saying that dx upon dt is equal to xt something, if you can provide me some example, okay, this will help me. You can write the problem on paper and WhatsApp me in the in the coming session. I will
ओके सर।
present an example corresponding to the problem. Okay.
ओके।
Yes, we can do. So sometimes when you put the question exactly, sometimes I am not able to understand, because the thought process we have different, but exactly sometimes I'm not catch the actual problem. So that's why if you can send your problems on WhatsApp, not only during the session, you can send anytime, but the
यस
problem should be associated with the existing lectures. Okay, mainly we are targeting the problems which are associated with ODE, ordinary differential equations. For PDE, we have the different slot. Okay, so all the problems which you are facing or you want to discuss, or if you want that the problem can be discussed during the session. So if you will send me the problem, this will help me to include in the coming sessions. Okay. Any more question, please? Okay, so I am going to share my screen, and you can see.
Hello, sir.
Hello.
Yeah. My question is, till now we are focusing only in the first order ODEs. Most of the problem we did, that is from first order. When we will handle the second order and high order, is this included?
Yes, yes, these will also be in the sequence. Okay, actually, did you saw the list of the methods which are available or which we include in the this course? Okay, so second order, third order, these will also will be there, but in the beginning, the sequence we cannot break. Just see
Okay,
once
okay, sir.
again. See once again. So this is not the part of the confusion. When you will visit on the website, and this is the course where you can find all the detail. Yes. So here is the course. Just 1 minute. Why it is appearing? Yes. Yeah. This is the main course. Okay. So here, when you will visit, see. So the sequence of the topic which are available at this place. This is the first method. Then we have the second. Then we have the third. Okay. And along with the, you can see, then we have this one. But before this, we need predictive corrector, which was not included at this place. So that's why we include at this place. Okay. So all these methods are going to cover in this sequence of topic which I have already put at this place. Okay. So all the methods are there. This method already discussed, but this method must be before, must be at this place. Okay. So we covered the same topic at this place before this one. Okay, because this Adam Bashforth is also based on predictive corrector. So that method will help you to understand this method. Okay, so all the topics which are available at this sequence, we are going to covering on this way. So all the second order, third order, higher order will be included also, and system of equations, systems of differential equations will also be discussed during the these sessions which we organize. Okay, so everything based on ODE we try to include, and if still you have such method which are not exist in this list, you can send us and we will include, because this is the not the limited. Okay, if you have some method which you want to suggest, welcome, we will also include that particular. Okay, so don't worry about, but I am following this sequence, I can't break this one. This is our basic proposed content we have to cover, but still if you have more method, you can send us, we will include that also. Okay, so these are the content, and now come at the place. So today the method which we are going to cover is Adams Bashforth method. Okay, so just we need to follow here. I am not focusing more about derivation of the method. Okay, because this method is based on using MATLAB, how we can implement MATLAB for these methods. Okay, so just you can see dy upon dx is equal to fxy, and this is the initial condition, and based on this condition we need to compute these values which are available at the place, and corresponding to this we have these functions f minus 1, f minus 2, and f minus 3. Then we have predictor and corrector which are defined at this place. So this equation is Adams Bashforth predictor formula. Okay, and along with we have the corrector, and corrector is given at this place. The corrector is this equation, which you can see here is the equation. Okay, so these two equations are given, which are Adams predictor and corrector, but this equation is known as Adams Morton corrector formula. Okay, so these two equations are very important, and on the base of these two equations we can easily establish the formula. But the thing is, again, as I told you that we need these formulas in the form of iteration, and for that today in the morning I share one PDF file, and in this PDF file you can see the entire detail which we need to discuss here. The Adam Bashforth predictor corrector method is numerical technique and used for solving ordinary differential equations. It's particularly effective for initial value problems where the initial state of the system is known and you want to predict the system's behavior over time. The fourth order Adams Bashforth predictor corrector method involving using the fourth order predictor followed by the fourth order Adams Morton corrector. Okay, so this is all about predictor and corrector. and the convergence also you can, I hope you have gone through this detail, but we will use through the MATLAB. So theoretical part I want to skip. I jump to our main task which is required. Okay, so here this is the these are the two equations which you can easily convert in iterative format. Okay, so when you will compare these two equations with the previous which I have shown you from the numerical method book, and you can easily convert in the form of iteration. Okay, so you can see this is the predictor equation and this is the corrector. So what is behind in this equation? This value will be initially computed, and will to make correct this value pass at this place. Okay, rest all the other functions are there, and where yn is the numerical approximation of ytn at time tn, and h is the step size. Fn will be equal to ftn yn, and if you want to correct this one, fpn plus 1 will be equal to ftn plus 1 yn plus 1 p. Okay, and this can be obtained from the predicted steps. Okay, so just we need these two equations. Now the main task is how we can implement these two equations for predictor and corrector. But remember that we need to compute these values first, which I have shown in this file. See at this place. So first what you are given only this equation and initial condition. We need to compute these values and these values. Okay, then after we can implement this formula, and to compute these values you can use Taylor series, Euler method, or Rankata method. Okay, we can use this one of these three methods, and then after we can implement Adam Bashforth predictor formula. Now come to in the MATLAB. I want to close this part, and this is our MATLAB. Along with we will check the stability and error difference using MATLAB, and I try to put here two examples. Okay, and this is very quite simple to implement. Yes, so okay, yes. So here first we are going to write the fourth order predictor corrector formula. Okay, so the file name I put at this place before PC. Okay, predictor corrector, and this will be the input arguments. F will be the differential equation, and T span will be the interval for time, and Y naught is the initial condition for Y, and N will be the number of steps. Okay, so these input arguments are required, and a little description about the same has been put at this place. And as you know that the comment statements are not the part of this programming. Only the statements which are in black color are the part of program. So first we will compute the value of h, and you know t span 2 minus t span 1 upon n. This will give us the size of step size. Okay, and then t will be the line space from this is the initial value or the first value of this interval. Okay, the first value and the last value. So t span 1 is the first value of the interval, and this is the last value of the interval, and these are the number of points which are required. Okay, so if there are step size is h, okay, and number of points will be n plus 1. So this vector, these point will be generated by using the step size. Okay, and will be saved in T, and corresponding to all these points we need y0 vector, as we do in all the previous examples. And this is also very quite simple. Length y naught and n plus 1, this will generate the same length of y as we have t. Okay, so the length of these two vector will be same. This must be always equal. Then what about this one? I have already told you about this statement in the second last lecture. Okay, so yes, so this is the what is the meaning of this one? You know, anyone can explain this statement? We are using this statement third time. This is the only index for y naught. Okay, this is the index for y naught. We are using y1, y2, y3, and so on. So this is the index for the initial value, why not? Okay. And then after we are using here to compute the values for fourth order, y1, y2, y3 and y4 corresponding to the index. We are using at this place Rankata method to compute the initial values which are required to implement this Adams Bashforth predictor. Okay, and you can see at this place the for loop which we are using is going to start from I equal to 4 to n. Okay, so corresponding to I1, I2, I3, and one value is also there, y naught. Okay, y corresponding to y naught we have come back. This is y1. Okay, so y1, y2, and y3. These values will be computed at this place, and that's why we are choosing this loop from 1 to 3. So initial three values which corresponding to for this method which are required will be calculated at this place, and those values will be used in the predictor. And this is the same equation which I have shown you at this place. Sorry, you can come back in this file, this one. Okay, this is the same as we are using here in the MATLAB. So here you can see this is the yi h by in the place of n we are using I. So only this is the difference. Just you need to replace n into I, and you will have the syntax for the method. And why we are using these three dot at the place? If you will have the statement long length and you want to break for the continuity, we have to use at this place three dot. And also you can remove this, but you can see now there is a same meaning. If you want to break, then you have to use these three dot for the continuity. The rest part of the statement is in the next line, so that MATLAB can understand there is some part on the next line. Okay, so that's why we use three dot. And again, this is the second equation corrector. Okay, the second equation from the formula. Okay, this one you can easily compare yn plus h by 24 9 fn plus 1 plus 19 fn n minus 2 n minus 1 n minus 2 and come back in the MATLAB. See, this is yn h by 24 9 f t I plus 1. This is the based on this predictor value. Then 19 f t I yi. Then we have f t I minus 1 yi minus 1, and these are ti minus 2 and yi minus 2. You can easily compare with this one. Just you need to replace n into I. So easily you can, when you are able to convert the formula in iterative format, then you can easily use the formula in MATLAB. So this is the entire part of the programming, and you need to save this file first. Okay, and after save the file, you can come at the place to implement it to solve any differential equation using this formula, this method. Okay, so we are choosing at this place. This is the f function dy upon dt. Okay, and by using anonymous function, we write at the place dy upon dt is equal to minus 2y. Okay, so this is our main differential equation, and this is the initial condition. Time span we are choosing at this place 0 to 5, and the number of steps we have 100. You can manipulate this equation, this condition, this interval, and this. Just you need to call this function which you create for Adam Bashforth predictor corrector. Okay, just you need to call this function and pass all the argument through the same. So when you will use at this place, okay, and you know the solution of this equation will be y will be depend upon t. So we need to require two arrays to plot the graph. Okay, so that's why we need two output, one is t and other is y, and the same we are using at this place to save the output values in t array and the other will be y array. Now by using the same we are plotting the function at this place. We have the plot function t y, t is at this place and y is here, which are stored, and the same we are using this is the marker of the graph. Then you can assign x label, y label, title and grid on. And when you will execute, you can see the graph of the corresponding differential equation. So in this way, you can easily write and you can implement the method. If you want to change, you want to take some more equation, like if you are choosing product, you are choosing here product T. Okay, you have new differential equation. You have now new differential equation, and when you will execute, and you can see the graph is like in this way. If you are choosing here some like sine, I'm taking at this place sine function. Okay, so this is again we have new differential equation, and when you will execute, and you can see the graph like in this way. Okay, and if you have at this place you can take minus y, yes, so you can manipulate any kind of differential equation. You can change the initial value, all the parameters what you required you can manipulate. You can play this code now. Once the code is successful, run. So I think there is no more doubt related to this method. If you have question, please feel free to ask from me. So every statement of the program is required how these statements are working, and I always try to explain every step. So most of the these initial conditions, this method are already discussed, and only we implement these two new equations. Only this part is new. And remember that you can easily write your programming only if method is clear and the formula which you want to implement, first you need to convert in iterative format. Then this will be easy to convert in the MATLAB syntax, and all the things are very simple. And the most important thing, as you know, how you can create the user defined function. Okay, so we create at this place user defined function for this method, and at this in this file we are computing the numerical values. Is there any question? Is there any question? At this place you can use other methods like Euler method you can use. Okay, if you want to use Milne method, that also can be used. So all the methods which we discussed earlier, you can use one of them to compute the values which we are using Rankata method to get the values which are used in this formula. Any question, please? Any question? No question? Okay. So once again, I am sharing my screen. So this was the first example. I want to close this file, and in the next file, second example. So here, okay. So here the input arguments will be same. Okay. And this is the same function which we are using at the base. Adams Bashforth fourth order. Okay, and the method is same, but the difference is that all the functions which are required to use, only the syntax difference is there. At this place we are using Rankata method. Okay, we can use also Euler method at this place to compute the values. See here. So the thing is that these functions which are involved at this place or in this equation are computed, we can write in this way. So all these functions, when you will use f1, f2, f3 and f4, you can see that now the size of this first predictor equation is now small by breaking in this way. Okay, and similarly the second equation is also in small size. Okay, so this is the predictor and this is the corrector. Both the equations are there, and at the end you can save the file and you can run at this place. So the other things are same. You can take any example with the initial condition. You can choose any interval what you want. Okay, step size, etc. And the other part are same as we do in the first example, and you can execute easily and you can get the result. So here, sorry, just 1 minute. I press the this one. Okay, you can see the graph of the function. We must run stop and run from this place. Yes. So this is the graph. Okay, you can now play with this code for different type of examples, first order differential equations. So all the methods which we discussed till now are for first order differential equations. Okay, and then we have the last, in the last example, what we have done. Yes, it's at the place we try to discuss about the error and stability you can do, but you know, when you want to find out the error, in that case we should have exact solution, and only then we can find the error. So here, what is the stability analysis and what is error analysis? All these things are similar as we discussed in the case of Rankata and Euler methods. Okay, so these are theoretical part, and the steps which we are required to implement at this place are the same. Okay, so the main thing is initial condition at t, h, n length of the parameter, initial condition, and OD, and this is the exact solution. The exact solution corresponding to this differential equation we have is this one. This is required. Okay, now we will use numerical approach for this differential equation using this method which we discussed just now. Okay, Adams Bashforth Praetor method. Okay, and this is the same process which we discussed here. You can use Rankta method, then you will use corrector, and then you will use corrector and Praetor at the place. Okay, so both the equations are same, only the syntax are different. So here we are using Praetor and here is the corrector. Okay, now you can easily compare these two results. We have three solutions are there. One is exact solution. This is the exact solution. Then we have, we can plot the predator also. Okay, and you know, corrector will depend upon the predator. So here is corrector. Okay, so the exact solution will depend upon t, and here predator is also depend upon t, and y corrector is also depend upon t, and the other are colors and markers also used at this place. And if you want to introduce legend always help us to recognize the graph. Okay, one is exact, and but when you are using legend, this must be same order as you are inserting the statement to plot the corresponding solution. Okay, and x label, y label, title, these are the same statement. You can execute, and you can see all the three graphs are in the same file, and on the top right hand side you can see exact solution is there, predator is there, and corrector is there. So this is the comparison between these solutions in the same file, and you can easily check which method is more accurate. But we will always compare these predator and corrector corresponding to the exact solution. Okay, so you can see the difference and you can easily compare. So this is the comparison and error also. And if you need in the numerical form, you can get the same also by using the same code. Okay. So this is all about this today's session. All the things which are required has been discussed. Now it is over to you if you have any question. Any question, please. Jitendra ji, namaskar. Good evening. Ananya, any question, please? The code of this file will be easily, just now I will WhatsApp. Okay, Seema Mandal, you just send the question on WhatsApp. I will check it and I will try to introduce in the coming session. Okay, so time is over and tomorrow we will join the session at the same time. If you have any question, please feel free to ask from me.
Good evening, sir.
No, good evening, Imtiaz.
Sir, I have a little bit confusion, not about today's session.
Yes, please.
I have no confusion about today's session, but I have a little bit confusion about my own personal problem about MATLAB. May I ask you on call, sir, if you will be free?
Yeah, if you have personal issue, you can discuss with me after the session.
Thank you, sir.
Yeah, always feel free to discuss with me.
Thank you, sir.
We are here to help you. So please don't hesitate.
Thank
If
you,
you
sir.
have
Little
any
bit.
question, always feel free.
I want to know about, sir, that Gaussian quadrature. Yes, quadrature, weights and abscissors.
If the problem is separate, then we will discuss after this session. Okay.
Sure, sir. Okay, sir. Thank
After
you.
the meeting. After
Thank
end
you.
this meeting. Okay.
Thank you, sir.
Yeah, you
Thank you,
can
sir.
call me. You can call
Okay,
me
thank you. Thank you, sir.
after this and after this meeting. Okay.
Sure,
Don't
sir.
hesitate.
Sure, sir.
So, dear colleagues, friends, and participants, so the today's session is over. The content which we discussed will be uploaded, and all the things are there. And if you have any question, please feel free to discuss with me. And also, what I will do, I will record today one more lecture and will be uploaded in your account. You can go through. And some participants who are attending this session, who are not registered, the same will be uploaded on the our playlist on YouTube. So all the things, whether you are registered or not, the recording will be available for all the participants. Okay. So one more method I will record and will upload it, and you must cover that lecture. So this will accelerate and will save our time. And we want to finish this and this entire methods within in the month of March. Okay, before 31st March, we want to finish this one. So there will be some recorded lecture you can go through, and I know there will be no issue. And as you are attending, I think when I present, I try to explain everything, and there is no question from your side. If you have question, I am always here anytime. So thank you very much to be part of this session. Good night.
Thank you,
Good night, all.
sir. Good night. Good night.
Good night.